All right, good morning. So we're going to take a look at 2D kinematics. We're going to look at number 2 from the guided practice. The first thing that I'm noticing with most students is that we're not visualizing. We're starting off doing physics, and we never want to start off with physics. Physics is difficult, so we want to start off with conceptualizing. So here we have a slingshot is used to launch a stone horizontally from the top of a 20-meter cliff. The stone lands 36 meters away. What speed was the stone launched at, and what is the speed and angle of impact? So the first thing we want to do is I want to graph like an illustration of what I'm looking at. So I know I have a stone. It's being launched off. It started at 20 meters high. It's going to end at the ground, and then this is 36 meters away. So once I have my diagram, then next I want to go ahead and compile all of the given and unknown information that we have. So this is going to be a vertical problem. So gravity is involved. So acceleration is going to be equal to gravity, 9.8 meters per second squared. We know what his initial y position is. That's going to be 20 meters. His final y position is going to be when it hits the ground, 0. Here, his initial x position is 0. Final x position is going to be 36 meters. And so now we can go from there. They're wanting us to find the velocity. It was launched horizontally, so we'll look for velocity in x direction. When we look at the kinematics, the first thing I'm looking at is we don't have time. As I'm looking at this, we can use kinematics to find out how long it would take to get here, so we can find time. So I'm thinking just off the top, we'll start from kinematics, and we'll just do a vertical problem. We'll only look at the vertical. So we'll go to our kinematic equations. So I'm looking at the kinematics. I'm looking for one that doesn't have time. So this is one that doesn't require me to use time. We can find we can find the final velocity in the y direction. We know what acceleration is. We know what initial y. So we want to find time. So we can solve for time. This one, we don't know what the final velocity is before it hits the ground, so I wouldn't use this one. This one doesn't require us to use final velocity, but we can use final y position, initial y position. Initial velocity, solve for t, and we know that acceleration is due to gravity, so this would be the one that I would use to find t. Yeah, we don't have a final velocity for this one, so we'll use this one. So we'll start off with writing out our equations. So we want x final to x initial plus v naught t. All right, so now we'll change these over to y, because we're going in the y direction. So now we've got an equation that's set up for y. We know what the final y position is. That's going to be 0. We know what the initial is 20 meters. Initial velocity is 0, so all that'll go is 0. 0.5 times 9.8. This will get negative because we're in the down direction. And then t squared. All right, and then we should be able to solve for t squared pretty easily for this one. So we'll move the 20 on over. So eventually, when we go through the algebra, we'll have t is going to be equal to the square root. And this will be on the opposite side, so that's negative 20 meters. And it's negative on this side, so when we came to the other side, it's positive. Oh, no, we got 5 both sides. You know what, let's just move it out. So we have negative 20 on this side. On this side, we'll have negative 4.9. And this is t squared. And we need to divide both sides by that. So we'll divide this side by negative 4.9. Divide over here by negative 4.9. So t is going to be equal to the square root of whatever that quotient is. So we'll just put it in the calculator. It's going to be about 4, so it's going to be about 2. And this should be in seconds. I'm looking at the units. The units aren't quite matching up. Oh, here we go. This would have been meters per second squared. Meter cancel, then square root of that's going to be seconds. Always make sure you're checking your units. So now we know the time that it took to go from here to here. And then, okay, so now we have the time. Now we can use the kinematic equations to find out what the final velocity was in the x position. So say kinematics, and so don't know initial velocity, x direction. Hold on 1 second. All right, so for this one, for velocity in the x direction, so we know it took 2 seconds to cover that. So in the x direction, it's just distance over time. So it covered 36 meters. And that's the time value. So then we'll just do the math. 2 over 36 is 18. All right, so that'll be our velocity in the x direction.